This 60-minute video, produced over 3 months, takes you on a deep journey into many different aspects of astrophysics. The Milky Way is the galaxy that contains the Earth, but if you could look down at the entire Milky Way, you would not see the Earth at all. Every point of light in front of you is a star as bright as the Sun, while the Earth appears as a speck of dust compared to them. To the Milky Way, even the largest stars are just tiny specks of dust, practically insignificant. But have you ever thought that even the Milky Way, with a diameter of 100,000 light-years, is just a speck of dust floating in the universe? Anyone who has carefully observed the night sky knows that sometimes you see an elliptical patch of light like this. This is not a nebula, but the famous Andromeda galaxy. Like the Milky Way, it is a massive galaxy containing countless stars, black holes, and stellar matter, but its volume is much larger than the Milky Way. This suggests that the Milky Way is not the only galaxy in the universe. In the far reaches of space, galaxies may be everywhere. This is a Hubble ultra-deep space image taken by the Hubble telescope. This image covers only 1/12.7 millionth of the entire sky, meaning this tiny area contains about 1,000 galaxies. This means that most of the bright spots you see in this image are magnificent galaxies like the Milky Way, which are normally hidden from view by the naked eye. Using data from a series of observations made by the Hubble Space Telescope, scientists have calculated that there are about 2 trillion galaxies in the universe, evenly distributed across the entire observable universe, which stretches 93 billion light-years in diameter. These galaxies form many filamentary cosmic webs, but most are small dwarf galaxies, some with fewer than 10 billion stars. Our Milky Way is a relatively large galaxy, containing over 200 billion stars, while galaxies in the pre-existing universe were even larger, reaching around 1 trillion stars. Actually no, although we know the number of galaxies in the universe, but each galaxy has a different size, no one can say exactly how many stars there are in the universe. If we assume that each galaxy has 100 stars, we can calculate that the total number of stars in the entire observable universe is 23 times the 20th power. This is an astronomical number that anyone can read directly. The sunlight you bathe in every day is one of these numbers. Perhaps only when we truly receive the existence of cosmic weapons will we discover that even the existence and lost variation of the Earth or even the Milky Way have no effect on the universe itself, let alone humanity. In human life, what is the reputation that we always strive for? Instead of blindly comparing ourselves with others, we should calmly feel the richness and diversity of the universe and nature. What is at the end of the universe? From Earth to the vast Milky Way, all the way to the end of the observable universe, the universe can actually be divided into 6 levels. This video will give you a picture of the universe on different scales. We know that there are a number of stars floating around in the universe, and the sun that you see every day is one of them. However, these stars are extremely sparsely distributed. Even the closest star to the sun, Billings star, is more than 4 kilometers away. 2 light-years away. The Earth beneath your feet is in action. The rotation and movement of the activities create day, night, and seasons. Planets also have satellites orbiting them. For example, Earth's naturally protected moon. Collectively, this system, centered on a star and including the surrounding planets, guardians, and stars, forms a star system. This system encompasses the entire universe. This is the first level of the universe. Next, let's zoom in from the fence posts to the hundreds of magnitudes. We found star clusters and nebulae. Star clusters are groups of rows upon rows of stars, as far back as the Neo cluster and the Blue cluster. Nebulae are beautiful clouds created after the explosion of stars. They are usually a few light-years across and are mainly composed of hydrogen, helium, and plasma. Nebulae also gather under the influence of gravity, gradually giving birth to new stars. Therefore, we can consider nebulae as both the address of stars and the cradle of new stars. This is the second level of the universe. In the 1920s, people believed that the Milky Way was the entire universe. This concept changed when astronomer Hubble discovered that Andromeda was actually an angel outside the Milky Way, and that there were hundreds of millions of other galaxies in the universe. The third level of the universe is made up of angels. On a commodity scale of light years, these galaxies are natural systems consisting of countless stars, nebulae, and various interstellar matter. The Milky Way, for example, is about 100,000 light-years in diameter and contains at least 200 trillion stars. When we zoom out to million light-year scales, we find galaxy groups and galaxy clusters. A galaxy group is a group of thousands of galaxy groups. The Milky Way is part of the local group, which contains about 5 or 7 galaxies. A galaxy cluster is a group of hundreds or thousands of galaxies. The local group is part of the Andromeda supercluster, a supercluster of 2 galaxies, each a meteoroid. There are countless more such superclusters in the universe, and the fourth level of the universe is made up of these superclusters. If we zoom out to a scale even larger than a supercluster, you can see how unimaginably vast the universe is. At this scale, it contains a whole web of cosmic experiences spanning hundreds of millions of light-years, bounded by the Great Wall of the Dragon and the Great Wall of the Corona Borealis, all built from individual heavens. Scientists estimate that the universe contains about 2 billion galaxies, surrounded by an infinite number of nearly empty voids, forming a filament-like cosmic structure. This is the fifth layer of the cosmos. Traveling billions of light-years, we eventually reach the sixth layer, which astronomers call the observable universe. Implementing the speed of light, this is the theoretical limit of what humans can observe, a spherical region with a diameter of 93 billion light-years. At such a scale, the existence or disappearance of human civilization has no effect on the universe. All we can do is cherish the fleeting moments in life. Our solar system is like something created from Venus. Each planet has its own unique features. For example, Earth has life, Saturn has rings, Jupiter has the Great Red Spot. The bright star you see today is the central body of the solar system. Around it are 8 planets and other smaller bodies of these planets. Venus is the closest to Earth. If you see a very bright star in the night sky, it is most likely Venus. Venus's dense clouds of sulfuric acid create the strongest greenhouse effect in the solar system, causing surface temperatures to exceed 400 degrees Celsius, making it the hottest planet in the solar system, where no life can survive. Mercury is the smallest of the 8 planets and the closest to the Sun. Its surface experiences extreme temperature differences between day and night, reaching a high of 427 degrees Celsius during the day and dropping to minus 172 degrees Celsius at night. Images transmitted by probes show that Mercury's surface is covered with impact craters of various sizes, somewhat similar to the Moon. Then there is the core of the solar system, the Sun. Its size may be beyond your imagination, equivalent to 1.3 million Earths. Every second, about 600 million tons of hydrogen fuse into helium, which sustains light and heat and transfers some of its energy to Earth. In fact, the energy that powers our bodies and our brains comes from the Sun. Alongside Earth, Mars could be humanity's future home. The Curiosity, Erie, and Zhurong rovers landed on Mars. Its surface is a reddish-orange color, similar to some areas on Earth, due to the presence of iron oxide in the soil. Farther out is the asteroid belt, containing about 500,000 asteroids, most of which are made of rock or metal. Sounds like a lot, right? Actually, all of them combined are smaller than the Moon. Outside the asteroid belt is Jupiter, the largest of the 8 planets in terms of mass and volume. Thanks to its powerful gravity, Jupiter has shielded Earth from countless meteorite impacts throughout history, acting as Earth's bodyguard. It also has a striking feature, the Great Red Spot, a giant anticyclonic storm twice the diameter of Earth. Then there's Saturn, a gas giant similar to Jupiter but without a solid surface, making landing impossible. Saturn's most impressive feature, however, is its unique rings, which consist of hundreds of millions of ice and snowballs, but which are predicted to disappear completely within 100 million years. The last 2 planets, Uranus and Neptune, are sister planets, both of which are icy and look very similar. Uranus is the only planet in the solar system that orbits the Sun in a flat orientation, while Neptune is the farthest planet from the Sun, at 4.5 billion kilometers away, and is famous for its diamond-shaped inhabitants. Behind Neptune is the Kuiper Belt, which is similar to the asteroid belt but much larger in diameter. Some of these larger planets can form spheres due to their own gravity. They are called dwarf planets, such as Pluto. Beyond the Kuiper Belt lies darkness, but this does not mean we have reached the end of the solar system. Our solar system is still surrounded by the Oort cloud, a vast region of debris left over from the birth of the Sun, which covers about 2 light-years. Only when humanity has completely passed through the Oort cloud will we truly leave the solar system. It is easy to imagine that even the solar system is insignificant in the grand scheme of the universe. So what is the point of our existence as humans? This is the Milky Way galaxy where humans live. It is one of the most common par-spiral galaxies in the universe. If you look at the Milky Way from above, you will see several giant spiral arms extending outward from its central region, eventually forming a typical spiral structure. The larger spiral arms are called the main spiral arms, such as the Sagittarius arm, the Orion arm, and the Hercules arm. Our solar system is located on the Orion arm, about 2 kilometers, 60,000 light-years from the center of the Milky Way. From Earth, every night when the sun goes down, we have the opportunity to see the spiral arms of the Milky Way, the milky white band of light stretching across the sky. Inside these arms are countless newborn stars, brilliant nebulae, and various types of interstellar dust, together forming the disk structure of the Milky Way, commonly known as the galactic disk, with a diameter of about 100,000 light-years. To put this in perspective, even if you could travel at the speed of light from one end of the Milky Way to the other, it would take at least 100,000 years. Therefore, it is very difficult for humans to travel across the Milky Way in a short time. The spherical core of the galactic disk is called the bulge. When we look at the Milky Way from the side, we see that the bulge protrudes higher than the disk, making it the thickest part of the Milky Way, reaching a thickness of 10,000 light-years. It is also the densest region of stars, containing tens of thousands to hundreds of thousands of stars per cubic light-year, including many red giants, each with a total luminosity thousands of times that of the Sun, making the Milky Way appear very bright. These stars orbit an invisible object at extremely high speeds, the supermassive black hole at the very center of the Milky Way, Rayleigh Sagittarius. Scientists estimate that the Milky Way contains between 100 billion and 400 billion stars, all orbiting the galaxy under the guidance of the black hole, forming this giant galaxy. Furthermore, the Milky Way is surrounded by a vast spherical halo, consisting of sparse interstellar gas, and a spherical disk, representing the outermost layer of matter in the galaxy. Looking further out, you can see the large and small Magellanic Clouds, satellite galaxies of the Milky Way, much like the relationship between the Moon and Earth. In summary, the structure of the Milky Way consists of 3 main parts: the galactic core, the galactic disk, and the galactic halo. Overall, the Milky Way is home to countless stars, nebulae, and celestial bodies of all sizes. But have you ever thought that even the Milky Way is just a point of light in the vast universe? Because there are more galaxies like this in the observable universe than there are grains of sand on Earth? Do you know why astronauts hide all the warnings with their instruments? What amazing sights have they seen when they look back at Earth from space? In 1987, astrophysicist John White first proposed the panorama effect, describing the psychological impact of this unique perspective when people look back at Earth from space. The endless black background of space makes them feel awe, as if they exist independently of the entire universe. In 2016, a US research team conducted a large-scale survey of astronauts who had flown into space and obtained a surprising result. The vast majority of astronauts who had flown into space said that they felt unprecedented and overwhelming negative emotions when looking back at Earth. One astronaut, who wished to remain anonymous, even said that he felt that humanity would be destroyed within 500 to 1 years, which made him feel sad about anything strange. China's first astronaut, Liu Yang, stated during his EVA that when he left the capsule and entered space, he felt a darkness that was so deep that it could be bottomless, indescribable. He said that this experience was a fascinating psychological shock, and he was even afraid to look into the giant space, afraid that he might drift away if he let go. However, astronauts choose to hide their full face of the app before it becomes too much. For example, their responsibilities require them to project a strong image. Showing sadness or fear would be seen as weakness, making future missions more difficult. Through the astronaut's perspective, we glimpse a macroscopic perspective beyond ordinary life, provoking a thought about the smallness of humanity in the universe and our responsibility as a kind of counterplanet to this planet. Looking out into space is also looking back at ourselves. The panoramic effect is not only an astronaut's experience, but also a treasure and possibility for all humanity. As Carl Sagan said, "On that pale blue dot suspended in the middle of the universe, everyone you love, everyone you know, everyone you have ever heard of will spend their entire lives there." This thought spikes a deep sense of inferiority, a shock from the heart, a profound sense of helpless failure. In a sense, the astronauts fortunate enough to venture into space have been shown the architecture of wonders that do not belong to humanity. They experienced the vastness of the universe firsthand, and the surprise they received may be something you and I will never truly understand. Voyager 1 miraculously came back to life. After a sudden outage and communication blackout in the war year, NASA restored contact with Voyager 1 this year. What happened this time around? On November 14, 2023, Voyager 1 sent data back to Earth as usual, but this time it received a string of gibberish characters. Even after rebooting the device, the meaning of the gibberish characters was still unreadable. Surely there would be many other devices on board that were still working normally. Scientists decided not to give up so easily. After a 6-month inspection, they finally discovered that the root cause of the problem lay in the Flight Data System, FDS, which was responsible for storing and processing data from the probe. 3% chip memory in FDS is irreparably damaged. On Earth, replacing the memory would be simple, but Voyager 1 was 24 billion kilometers away, a journey that would take nearly a day even at the speed of light. So NASA engineers had to rewrite the code, scattering and rearranging the corrupted data, storing it in multiple locations in the memory. This allowed them to bypass the 3% that was corrupted. On April 18th, ground crews sent the code to Voyager 1 via the Deep Space Network. It successfully received it a day later and then transmitted the revised data back to Earth a day after that. Amid the anxious wait of ground crews, Voyager 1 finally woke up. Scientists were delighted. No one imagined that Voyager 1 would orbit in space for 46 years, when its original design lifespan was just 2 years. This is because it uses nuclear power, which generates electricity from the decay of the radioactive isotope Part-238. Voyager 1 is expected to run out of power by 2025, at which point scientists will no longer be able to communicate with it. So the interstellar data Voyager 1 will receive over the next 2 years will be increasingly valuable. Notice that pale blue dot? It is home to 8 billion people. On February 14, 1990, scientists had a brilliant idea. Have the Voyager 1 probe 6.4 billion kilometers away, look back at Earth and take this spectacular photo. In this family photo of the solar system, Earth is just a faint, inconspicuous blue dot, occupying just 0.12 pixels, a stark reminder of humanity's insignificance in the vastness of the universe. 34 minutes after taking this photo, it turned off its camera and headed into deep space. At its current speed of 17 kilometers per second, it will reach the Oort cloud at the edge of the solar system in about 300 years, a journey that will take 30,000 years to complete because the gravity of the solar system stretches over 2 light years. While we may not be able to leave the solar system in our lifetimes, the metal record that Voyager 1 carries, containing greetings in many languages and sounds of nature, will serve as proof of humanity's existence in the universe. Many fear that it will lead to extinction, given the cruel laws of the universe. However, we need not worry too much. The universe is vast and the distances between objects are immense. The chances of the record being found by aliens are extremely low, and no one knows the ultimate fate of Voyager 1. With billions of exoplanets in the universe, why haven't we found life beyond Earth? There's actually only one reason. Earth is the only planet known to have life, But scientists have discovered that most of the natural laws that govern Earth also apply to other planets in the universe. This means that since any life on Earth cannot exist without sunlight, air, and liquid water, we can be pretty sure that life beyond Earth also needs these things. Scientists estimate that the Milky Way galaxy contains 200 billion stars, of which 10 million are in the habitable zone, and more than 100,000 have the potential to support life. The entire observable universe contains at least 2 trillion interstellar objects. With such a large number, the existence of life beyond Earth is almost inevitable. Yet, to date, we have not discovered any extraterrestrial life. Where is it? This is the famous Fermi paradox, a question that has fueled the wildest human imagination about extraterrestrial life. Some speculate that the universe is simply too vast. Take our own Milky Way galaxy, for example. The average distance to the habitable planetary boundary is 5,000 light-years. Even traveling at the speed of light, such a distance would require tens of thousands of years to communicate, making such a huge cost and risk to encounter a completely alien planet not worth it. As we know, almost every tiny point of light in the bright night sky is a star like our Sun, with planets orbiting it, and possibly even super-Earths in the habitable zone, capable of supporting Earth-like life. Imagine what their world would be like. Would it be a futuristic metropolis with towering skyscrapers and incredibly sophisticated technology? Or a hellish landscape with lightning and lava flows? We have no way of knowing because the universe is incredibly vast. Not only are galaxies at least millions of light-years away from Earth, but even the nearest star, Pillin, is 4.2 light-years away. With current technology, even spending 10,000 years would not be enough to get there. Despite the vastness of the universe and the countless celestial bodies, unfortunately, this huge distance limits our ability to discover extraterrestrial civilizations. One civilization cannot determine whether another is benevolent or malevolent. Therefore, the universe is like a dark forest, and each civilization is an armed hunter, forced to keep a close watch. When encountering another civilization, the only option is to shoot it down and destroy it. Over the 13.8 billion-year history of the universe, most planets have probably been inhabited by simple life forms that lacked the ability to explore the cosmos. Earth, incidentally, was the first planet to show signs of intelligent life. Another possibility is that aliens simply don't care about Earth, just as we wouldn't pay much attention to the movements of ants. There are far more planets than stars in the Milky Way, and some extraterrestrial civilizations are capable of roaming the galaxy, theoretically having an infinite number of planets to choose from. Therefore, from a macrocosmic perspective, extraterrestrial life must be everywhere. It simply lives in space beyond the light, beyond the reach of human observation. Do you know what the edge of the universe looks like? If humanity were to fly this faster-than-light spaceship, traveling at a distance of 1 light-year per second, how long would it take to reach the edge of the universe? At this speed, it would take just 1 second to reach the Oort cloud, the boundary of the solar system. This is a spherical region 2 light-years in diameter that encompasses the entire solar system. For seconds later, we would reach the closest star system to our Sun, Billings Centauri, a triple star system and home to the Trisolarans. 8 seconds into the flight, you would see a bluish-white star called Alanine, a typical blue dwarf and the brightest star in the entire sky. "20 seconds later, we would reach Gliese 581g, a home planet just 20.5 light-years from Earth. Some scientists even believe that there is a 99% chance that life exists on this planet. 7 minutes into our flight, we passed the closest star cluster to Earth, the Ma cluster, which contains over 3,000 stars and spans 13 light-years. 10 minutes into our flight, we passed by the Shinsusa Temple, an old star near the end of its life, about to undergo a catastrophic supernova explosion. 25 minutes into our flight, we passed by the Orion Nebula, one of the most beautiful nebulae in the universe. A step inside reveals countless newborn stars being born within. 2 hours into our flight, 3 giant pillar-like nebulae come into view, the pillars of creation within the Eagle Nebula. Their breathtaking beauty has earned them a place among the most beautiful nebulae ever imaged by the Hubble Space Telescope. 5.5 hours later, we arrive at Stephenson 218, currently the largest known star, with a mass about 10 billion times that of the Sun, enough to hold 1.3 trillion Earths. 7 hours later, as the density of stars increases, we reach the center of the Milky Way, where a supermassive black hole, Sagittarius A*, guides most of the galaxy's stars in its orbit. After a day's flight, we finally leave the Milky Way, now clearly visible in its entirety. Astronomers estimate its diameter to be around 100,000 light-years, containing between 100 billion and 400 billion stars. A month later, we arrive at the Andromeda Galaxy, the closest galaxy to the Milky Way, containing 1 trillion stars like our Sun and one of the most distant objects visible to the naked eye in the night sky. 2 months into the journey, we left the local group, a small galaxy cluster of about 50 galaxies, including the Milky Way. 2 years later, we discovered that the local group is actually located within a much larger galaxy cluster, the Andromeda supercluster, with a terrifying diameter of about 1.1 light-years. After a 12-year journey, we left the Laniakea supercluster, a giant, feather-thin structure containing at least 100,000 galaxies and measuring an astonishing 520 million light-years in diameter. As the spacecraft continued its journey, we saw ever-widening webs of galaxies. But our real destination came after more than 1,400 years of travel, the edge of the observable universe. This is the limit of the observable universe, but not the actual size of the universe. The real universe is 250 times larger. Even at such incredible speeds, we could only reach this point because the universe continues to expand faster than the speed of light. What lies beyond this universe? Is it an even larger expanse of space or countless parallel universes? We may never know. In the Milky Way galaxy, our Sun is located in the Orion suspension, which forms this vast and beautiful system of hundreds of billions of stars. On clear summer nights, we see a milky white band of light. This is the Milky Way, but it is only a part of the galaxy itself. Every star in the Milky Way orbits its center. The Sun, along with its 8 planets, takes 250 million years to complete one orbit around the galactic center. This is called a galactic year. However, beyond the magnificent Orion suspension, even more striking is the extremely bright center of the Milky Way, called the galactic center, a spherical region of light 20,000 light-years in diameter and 10,000 light-years thick. Why is it so bright? Now, let's travel to the center of the Milky Way and find out. As we get closer to the galactic center, we find that it is filled with ancient stars that are billions of years old and red giants that are thousands of times brighter than the Sun. Moreover, the closer we get to the center of the Milky Way, the greater the density of stars, eventually reaching unimaginable levels. Astronomers estimate that this region contains a huge number of stars and nebulae, averaging more than 290,000 stars per light-year. This means that if we lived nearby, we could read a book normally at night without turning on the lights. Therefore, the reason the center of the Milky Way is so bright is because of these dense stars. Of course, astronomers have also discovered a supermassive black hole at the very center of the Milky Way, about 2 kilometers from Earth. Located 60,000 light-years away, Sagittarius A* has a mass about 4.3 million times that of the Sun. In May 2012, the first image of Sagittarius A* was officially released by the World Telescope collaboration. This black hole plays an important role at the center of the Milky Way, forming a parasitic galaxy with at least 200 billion stars, stretching over a diameter of about 100,000 light-years, the Milky Way we know. Right now, we humans are living in a corner of the Milky Way, on Earth around a yellow dwarf star. But the fame and money we achieve throughout our lives are actually insignificant compared to the vastness of the universe, because we are extremely small. So whenever we feel sad, we should look up at this magnificent and brilliant universe. The Earth is like a speck of dust in the universe, and that's no exaggeration, because the vastness of the universe is beyond our imagination. So what is the universe really like? This video will take you from Earth to the endless depths of the universe to explore its unknown secrets. Our first stop is the Moon, the closest celestial body to Earth and the only extraterrestrial body humans have ever set foot on. The craters on the far side of the Moon record billions of years of its history. Next, we go to Mars, the most Earth-like planet. Although its surface is desolate and barren, it is a place Elon Musk has dreamed of visiting. Soon, we pass through the asteroid belt, a dense region of at least 500,000 asteroids, the largest of which is called Archaea, which is about 950 kilometers in diameter. Next is Jupiter, the largest planet in our solar system, 1,321 times the size of Earth. Its surface has a storm vortex larger than the diameter of Earth, called the Great Red Spot. Saturn is considered the most beautiful planet in the solar system, thanks to its remarkable rings containing billions of tiny ice crystals, each a small moon. Next are Uranus and Neptune, two ice giants at the outer edge of the solar system, followed by the famous Kuiper Belt. To date, 5 probes have visited this region. Scientists speculate that our solar system is surrounded by a giant spherical cloud called the Oort cloud, about 2 light years in diameter, which is the true edge of the solar system. Outside the solar system, you will see increasingly bright points of light that resemble fireflies. Each point is a star, which together form the Milky Way galaxy. Above the Milky Way is the even larger local group, containing more than 50 galaxies, with a staggering diameter of 10 million light-years. Above the local group is the Virgo supercluster, a vast region more than 110 million light-years in diameter containing more than 100 structures similar to the local group. Then, just down the road is the Laniakea supercluster of galaxies, with a staggering diameter of 5. At 200 million light-years wide, it contains at least 100,000 galaxies. At this stage, the universe is no longer a uniformly distributed galactic structure, but a network structure. Hundreds of millions of galaxies, propelled by dark matter and dark energy, have become cosmic walls that span billions of light-years, with superclusters becoming nodes on these walls. They are separated by cosmic voids that are tens of millions to billions of light-years wide, extending to the edge of the observable universe. Currently, the observable universe is a spherical spacetime with a diameter of 93 billion light-years, centered on the Earth. Because the universe is expanding faster than the speed of light, and because the speed of light is limited to 300,000 kilometers per second, the extent of the universe we can see is finite. Since the speed of light cannot counteract the expansion rate of the universe, light from outside the observable universe will never reach Earth, so we will never see what lies beyond. What lies beyond this? No one knows, and there is no way to know. As the saying goes, we are just a grain of sand floating in the vast ocean of heaven and Earth. We are just grains of sand in the universe. On the macro scale of the entire universe, even the entire human civilization would be small. So why are we so obsessed with so-called fame and fortune? Why is the location of the Earth so coincidental? Is the Earth really that special in the universe? As we know, the Earth is the only planet known to have life. Its uniqueness lies in its magnetic field and atmosphere. Together, these factors form the Earth's natural barriers, blocking cosmic rays and solar radiation, ultimately allowing life to develop on Earth and protecting it from the harsh outside environment. Furthermore, Earth lies in the habitable zone of the solar system, neither scorched by its proximity to the sun nor frozen by its distance, allowing water to exist in liquid form, which plays a crucial role in the origin and proliferation of life. So, what are the environments on other planets in the solar system like? This is Venus, which is closer to the sun than Earth, and therefore receives much stronger solar radiation. Its slow rotation and dense atmosphere create the strongest greenhouse effect in the solar system, causing surface temperatures to reach 460 degrees Celsius, making it impossible for life to exist there. This is Jupiter, which looks as beautiful as an oil painting. But once you dive into Jupiter's Great Red Spot and witness a superstorm larger than Earth, you'll change your mind. Jupiter's atmosphere has a pressure at least 250,000 times that of Earth, something no probe can withstand. This is Neptune. Despite being the outermost planet in the solar system, Neptune rains diamonds, but it is 4.5 billion kilometers from the Sun. Neptune's surface is extremely cold, with temperatures as low as minus 218 degrees Celsius, hence its nickname, Green Hell. The harsh environment on these planets is unsuitable for any known life. In contrast, only Earth, with its moderate distance from the Sun and relatively mild temperatures, can support life. So, is Earth really that special? And why is its location so coincidental? This question has always intrigued us. If we shift our perspective to the Milky Way galaxy, which lies outside our solar system, the answer becomes clear. We all know that in the Milky Way alone there are more than 200 billion stars, of which about 10 million are in the habitable zone, and more than 100,000 of them are capable of supporting life. Based on images transmitted by the Hubble Space Telescope, it is estimated that there are at least 2 trillion galaxies in the entire observable universe, each containing tens to hundreds of billions of bright stars. Most of these stars, like our solar system, possess complex planetary systems. Earth is special because, compared to most other planets, it is fortunate enough to be located in the habitable zone of its star, giving it the opportunity to evolve into modern humans. However, throughout the entire Milky Way, countless Earth-like planets harbor life. Perhaps when you look up at a star, there are beings like us standing on Earth, looking up at us from around it. Although current technological limitations prevent humanity from discovering any extraterrestrial civilizations, we have reason to believe that the universe is filled with many brilliant planets like Earth. Why is the universe always dark? Can't hundreds of millions of bright stars illuminate the entire universe? This seemingly simple question actually holds the ultimate mystery of the universe. In 1823, German astronomer Robert Opus raised a similar question, stating that if the universe were static and homogeneous, then after a long enough time, the night sky we see would be filled with bright stars, eventually achieving the same effect as daytime. But in reality, although we can see a sky full of stars, the night sky is usually dark, with large dark patches between the stars, and we cannot see the light of the stars in these spaces. This is the dark sky paradox. How to explain this? Opus' answer is that at least one of its three assumptions about the nature of the universe, infinity, uniformity, and staticity, is incorrect. Deep space images taken by the Hubble telescope have confirmed beyond doubt that the structure of the universe on large scales is uniform. So, is the universe finite? If the universe were finite, or the number of stars in the universe were finite, then the phenomenon of the dark night sky could be easily explained, because a finite number of points of light could not fill an infinite night sky. But the question is the starry sky that we see with our naked eyes really the entire universe? Obviously not. First, the universe is only 13.8 billion years old, which is fundamentally different from an infinite amount of time. Furthermore, given the limit of the speed of light, the amount of light that we can receive is finite. Theoretically, light from 13.8 billion light-years away has not yet reached Earth. Therefore, the universe is not infinitely large, at least not the observable universe. Is the universe static? In the early 20th century, Hubble observed a very important phenomenon, the redshift of galaxies. Almost all distant galaxies are moving away from us, and the farther they are, the faster they recede. This means that the universe is not static, but is expanding rapidly like an inflating balloon. Even light from the observable universe that could reach Earth would be stretched by the expansion of the universe, eventually becoming infrared light, invisible to the naked eye. This is one reason why the universe appears dark to us. Furthermore, not all light from stars reaches Earth. According to Einstein's theory of relativity, no object with mass can exceed the speed of light. However, this does not mean that space itself cannot exceed the speed of light. Therefore, places far enough away from us can move away from us at speeds exceeding the speed of light, resulting in us being able to observe only a limited number of celestial objects and receiving a limited amount of light. Furthermore, the energy of this light is constantly decreasing, so the night sky we see is not bright but dark. So why are stars millions of times larger than the Earth being swallowed by black holes? As we know, a black hole is not a literal hole, but a celestial body with a gravitational pull so strong that even light cannot escape. Since light cannot escape from inside, we cannot see it. Black holes take advantage of this property to hide themselves in the universe. However, their own enormous gravitational pull cannot be hidden. What you see now is an unfortunate star that has entered the gravitational field of a black hole. Now it is tightly bound by the enormous gravitational pull, and the next step is to be torn into countless fragments, finally swallowed by the black hole. The closer these fragments are to the core of the black hole, the faster they orbit the black hole. These stellar fragments also produce light through friction with each other, which is how telescopes capture images of black holes. Why do black holes have such enormous gravitational pull? It all starts with the evolution of stars. Current theories suggest that the more massive a star is, the faster its fuel is consumed, resulting in a shorter lifespan. As a massive star reaches the end of its life, its internal nuclear fusion no longer generates enough outward pressure, causing its outer layers to collapse inward under the influence of gravity, eventually forming a singularity of infinitely small volume and infinitely large mass, the birth of a black hole. Einstein believed that gravity is essentially a curvature of spacetime. The more massive an object, the greater the curvature of spacetime and the stronger its gravitational effect. Black holes, these indiscriminate monsters, devour anything that comes close to them, including other black holes. As for what lurks inside a black hole, we may never discover this mystery. However, we can be sure that black holes are both terrifying forces capable of destroying all celestial bodies and the magical source of birth of galaxies. It can even be said that without black holes, there would be no humanity. This is one of the most spectacular cosmic spectacles that humanity has ever witnessed. On July 17, 1994, comet ASIO-9 collided with Jupiter in a series of violent collisions, releasing energy equivalent to 40 trillion tons of fireworks. If this comet had hit Earth, humanity's fate could have been like that of the dinosaurs. The comet had been captured by Jupiter's gravity since the 1970s, but due to its small diameter of only a few tens of kilometers, scientists remained unaware of its existence until 2 years before the collision, when it was discovered that it had entered Jupiter's Roche limit and been torn into 21 pieces. At that time, comet ASIO-9 was only 45,000 kilometers from Jupiter, allowing scientists to accurately predict the moment of impact. The Hubble Space Telescope and the Galileo spacecraft, en route to Jupiter, both turned their lenses to witness this rare astronomical spectacle. As predicted, on July 16, 1994, the first fragment of ASIO-9 entered Jupiter's atmosphere at a speed of 60 kilometers per second. Over the next week, 20 fragments collided with Jupiter, creating intense bursts of light. The largest fragment was over 4 kilometers in diameter and had the energy of a single fragment equivalent to trillions of tons of explosives, creating a giant black spot that stretched tens of thousands of kilometers across the surface of Jupiter. The rays of light were even visible from Earth. The collisions continued until the afternoon of the 22nd, when the last fragment hit Jupiter, ending this spectacular cosmic event. According to the instrument, the fireball created by the collision stretched nearly 1,000 kilometers across and reached a temperature of 30,000 degrees Celsius. The falling rain even rose 3,000 kilometers above the cloud tops. Even more terrifying, the cloud of debris from the collision lasted for nearly 6 months, leaving a trail even more distinct than the Great Red Spot. The collision gave scientists the opportunity to study the composition of Jupiter's atmosphere, as it ejected a multitude of substances. Spectroscopy instruments detected lines of diatoms, carbon dioxide, and heavy elements such as silicon and iron. The collision also caused turbulence and disturbances throughout Jupiter's atmosphere. If life existed there, the collision would have been catastrophic. What would have happened to humanity if this comet had collided with Earth? Scientists speculate that if ASL 9 had been captured by Earth in the 1970s, it would have taken about 20 years to hit in 1994. With current technology, various methods could have been used to destroy it or change its orbit. Even in the worst case, some preventative measures could have been taken, such as preserving the seeds of civilization, to ensure that humanity would not be completely wiped out. Why do astronomers believe that humanity will never reach the edge of space? Watch this video and you will understand. This is what you see from Earth. To us, the Earth is so large that it cannot be said to be a sphere. This is a photo taken by astronauts in low Earth orbit. At this point, the Earth's surface begins to appear, debunking the theory of a flat Earth. This photo, taken 29,000 kilometers from Earth, shows what Earth looks like in the minds of many people. We can clearly see the entire Earth. This is a photo taken by astronauts on the Moon. At this distance, we are 380,000 kilometers from Earth. Facing the home of 8 billion people, many people feel both familiar and strange. Freed from the Earth's gravity, we enter the perspective of the solar system. Earth begins to shrink significantly. This is a photo taken by the Curiosity rover on Mars, 160 million kilometers away. Our Earth becomes a small white dot. This is a photo taken by Cassini from the rings of Saturn, 1.4 billion kilometers away, on its return journey. If I didn't tell you, you wouldn't even believe that Earth is there. Finally, there's this photo called the pale blue dot, taken by the Voyager 1 spacecraft from 6.4 billion kilometers away. Earth occupies just 0.12 pixels in the photo, insignificant as a speck of dust, highlighting the tiny size of humanity in the vastness of the universe. Voyager 1, currently the farthest human-made probe from Earth, has been traveling through space for 46 years and is currently 24 billion kilometers away. Even traveling at the speed of light, that distance would take nearly a day. However, the true gravity of the solar system spans 2 light years. At its current speed of 17 kilometers per second, it would take about 300 years to reach the Oort cloud at the edge of the solar system and another 30,000 years to pass through it. Above the solar system is the Milky Way galaxy, 100,000 light-years in diameter, containing at least 200 billion stars. Above the Milky Way is the even larger local group, containing more than 50 galaxies, with a massive diameter of up to 10 million light-years. Above the local group is the Virgo supercluster, a vast region exceeding 110 million light-years in diameter, containing more than 100 structures similar to the local group. Next, online, we find the Laniakea supercluster, a massive diameter of up to 520 million light-years, containing at least 100,000 galaxies. At this stage, the universe is no longer a uniformly distributed galactic structure, but a network. Driven by dark matter and dark energy, billions of galaxies form cosmic walls that stretch for billions of light-years, with superclusters acting as nodes. These walls are separated by cosmic voids that range in size from tens of millions to billions of light-years, stretching all the way to the edge of the observable universe. Scientists speculate that the universe could be as much as 250 times larger than the observable universe. With current technology, leaving our solar system is an impossible feat, let alone interstellar travel beyond the speed of light. Therefore, astronomers believe that we will never reach the edge of the universe. A light-year is the distance light travels in a vacuum in a straight line in exactly 1 year, which is about 9.46 trillion kilometers, equivalent to orbiting the Earth more than 200 million times. This number is probably unimaginably large. Let's explore the time it takes different modes of transport to travel a light-year. If we calculate based on a human running speed of 10 kilometers per hour, traveling 1 light-year would be a feat that would take 100 million years. Next, consider a motorcycle. If a motorcycle could travel at a constant speed of 60 kilometers per hour, it would still take 18 million years to travel 1 light-year. Then there is a car. Assuming it travels at a constant speed of 120 kilometers per hour, it would still take 9 million years to travel 1 light-year. Even a high-speed train, which can reach speeds of 350 kilometers per hour, would still take 3 million years to travel 1 light-year. Finally, consider a commercial airliner, one of the fastest modes of transportation available to the average person. If it flew at 900 kilometers per hour, the journey to 1 light-year would take 1.2 million years. This is the Concorde supersonic aircraft, capable of soaring through the sky at 2,450 kilometers per hour, but it still takes 440,000 years to travel 1 light-year. This is the Voyager 1 probe, currently the farthest man-made probe from Earth. It has been traveling in space for 46 years, but is only 24.3 billion kilometers from Earth. At a speed of more than 60,000 kilometers per hour, it would take about 17,000 years to travel 1 light year. This is a sublight speed spacecraft. If humanity could invent such a high-tech spacecraft and travel 1 light year at 1% the speed of light, it would still take a full 100 years, truly unimaginable. Is a light year really that far? In fact, compared to the observable universe, which is 93 billion light years in diameter, it seems insignificant. But don't underestimate this tiny light year, because in fact, our solar system is surrounded by the Oort cloud, which is about a light year in radius. Only by passing through this light year-sized Oort cloud can humanity truly be said to have left the solar system. Therefore, if humanity cannot break the light speed barrier, it may never be able to leave the solar system. And looking at the Milky Way galaxy, with a diameter of 100,000 light years, it is an unattainable dream for humanity. A dream that will never come true in our lifetime. Billions of years from now, all traces of human civilization will be wiped out. No matter how brilliant the achievements, they will disappear forever, as if they never existed. How long will it take for the fastest spacecraft today to travel a light year? As we know, light travels in a straight line in space in a year, covering a distance of approximately 9.4607 trillion kilometers. To put that into perspective, the distance around the Earth is only 0.0004 billion kilometers, and the distance between the Earth and the Sun is only 150 million kilometers. Therefore, for humanity, a light year is an insurmountable distance. Currently, the fastest man-made probe is Voyager 1, launched by the United States, reaching a speed of 61,200 kilometers per hour, 60 times faster than the speed of a commercial airliner. Sounds fast, right? But in fact, it is only 1/10,000th the speed of light. Since its launch in 1977, Voyager 1 has been continuously using the gravitational slingshot effect of the planets to accelerate itself. Currently, Voyager 1 has entered the gravitational wave zone and is about 24 billion kilometers away from Earth. Although Voyager 1 can travel at speeds of over 60,000 kilometers per hour, it would still take it 17,000 years to travel a light year at that speed. Hard to imagine, right? In 2018, the United States launched what is believed to be the fastest human-made spacecraft ever, the Parker Solar Probe. After several gravitational collisions with Venus, the spacecraft finally reached an instantaneous speed of 690,000 kilometers per hour as it approached the Sun, equivalent to 0.06% of the speed of light. This is almost the limit of the speed that humans can imagine. Unfortunately, even if a manned spacecraft achieved this speed, it would still take it more than 1,500 years to travel a light year. Knowing the truth, you can be amazed at the vastness of the universe and the length of time. However, don't be too discouraged. There are actually 2 other ways to travel between stars. The first is to master propulsion technology, using a special substance or energy to bend spacetime, allowing spacecraft to reach speeds faster than light without violating the theory of relativity. The second is to find wormholes that allow free travel in the universe. However, these are only theoretical possibilities, and at present, they are simply unrealistic, like something out of a science fiction movie. We find it difficult to travel even a light year, let alone the nearest star to our Sun, which is 4.2 light years away, and the nearest interstellar object to the Milky Way, which is 2.54 million light years away. The diameter of the entire observable universe is a staggering 93 billion light years. The universe is so vast that it defies our imagination. This is the largest known star, equivalent to the size of 10 billion suns, capable of colliding with 1.3 trillion Earths. It is 23 times larger than the previously discovered U1 Scuti. This is Stephenson 218, a star in the constellation Scutum, with a diameter of about 2.98 billion kilometers, equivalent to 2,158 times the diameter of the Sun. If Stephenson 218 were located at the center of our solar system, Mercury, Venus, Earth, Mars, Jupiter, and Saturn would orbit in its belly. But these planets wouldn't even be a drop in the ocean for Stephenson 218, as its volume is large enough to hold 10 billion suns. Despite its enormous size, its mass is only about 18 times that of the Sun. Why such a big difference? Primarily because it is in the final stages of its primary supergiant phase, a red supergiant. When a star reaches the stage, its internal helium is ignited through nuclear fusion, and the internal pressure causes its outer layers of gas to expand rapidly, leading to an ever-increasing volume. However, the outer layers of this celestial body are made up of extremely thin gas, much thinner than Earth's atmosphere, meaning it has reached the end of its life and begun the countdown to extinction. Stephenson 218 is 440,000 times brighter than the Sun, but it is so far away from Earth, about 20,000 light-years away, and is shrouded in interstellar dust, making it difficult to detect. However, astronomers finally spotted it using a deep infrared detector. Compared to Earth, Stephenson 218's volume is equivalent to 130 million Earths, or 13 followed by 15 zeros, an astronomical number so large that Earth looks like a grain of sand next to it. Stephenson 218 is not considered the largest star in the universe, however, because the universe is so vast. The Milky Way alone contains hundreds of billions of stars. If we could peer into a universe larger than the Milky Way, we would find galaxies everywhere, each containing an incredible number of stars, but those stars are too far away for us to observe. Among these galaxies, we are sure that there are stars larger and brighter than Stephenson 218. In other words, although Stephenson 218 is currently the largest known star, it is insignificant in the vastness of the universe. The radius of our solar system is about 9.4607 trillion kilometers, while the radius of Stephenson 218 is only 1.5 billion kilometers. Humanity has never stopped exploring the universe, and we know how small we are and how vast the universe is. Even a monster like Stephenson 218 appears as a mere speck of dust in front of the universe. Therefore, the vast universe may not care about our actions on Earth. Sometimes it is better to put aside worldly worries and pursue the life we truly desire. Why can black holes tear apart celestial objects? Where do the matter sucked into black holes end up? Do they lead to another parallel universe? Or do they disappear from this universe altogether? As we know, black holes are mysterious celestial objects, invisible to the naked eye. So how do we discover them? Pay attention to this bright ring. This is the accretion disk that forms when a black hole is consuming celestial objects. Before countless fragments of celestial objects fall to the surface of the black hole and are completely swallowed, they orbit it at extremely high speeds, creating a bright, incandescent light through mutual friction. This is one way we can observe black holes. In April 2019, the first image of a black hole was released to the public. It was a black hole located at the center of the galaxy M87. Although we can only see the halo around it, we can be sure that a black hole is hiding there. If a star enters the gravitational field of a black hole, it will be directly attracted by its extremely strong gravitational field. According to Newton's law of universal gravitation, the more massive a black hole is, the stronger its gravitational field will be. However, the strength of gravity depends not only on the mass of the object but also on the distance between them. If a star enters the gravitational field of a black hole, the side facing the black hole will experience a stronger gravitational force than the other side. This difference in gravitational force will cause the celestial body to slowly stretch into a noodle shape. This is called the spaghetti effect. So, does everything that is sucked into a black hole really disappear? In fact, Einstein's general theory of relativity states that gravity is a phenomenon of spacetime curvature caused by mass. The spacetime of a black hole is virtually infinite, and all the matter sucked in will eventually be crushed into powder and fall to the base located at the center of the black hole. However, where this matter goes after flowing into the center of the black hole is still unobservable and unknown. After all, the escape velocity within the boundary of the black hole exceeds the speed of light, and all information, including photons, is locked inside, never to escape. Therefore, the scientific community has not yet reached a definitive conclusion about this ultimate mystery of the inside of the black hole. However, one thing is certain. As the black hole swallows each celestial body, its mass increases, and it becomes larger and larger with each swallow, like an insatiable abyssal monster. Renowned physicist Stephen Hawking has proposed that black holes do not exist forever. They too gradually evaporate through radiation, albeit at an extremely slow rate, even exceeding the age of the universe. It is estimated that a black hole the size of the Sun would take 67 to the 67th power of years to completely evaporate. Although the entire process of evaporation is extremely slow, it tells us that nothing in the universe is permanent. Not to mention humans, even black holes will eventually meet their end. This is an astronomical number that is hard to imagine. The Earth is a mere grain of sand compared to it. However, people do not consider Stephenson 218 to be the largest star in the universe because the universe is simply too vast. The Milky Way alone contains hundreds of billions of stars. If we could look into the universe larger than the Milky Way, we would find galaxies everywhere, each containing an incredible number of stars, but those stars are too far away for us to observe. Among these galaxies, we have always believed that there are stars larger and brighter than Stephenson 218. In other words, although Stephenson 218 is currently the largest known star, it is insignificant in the vastness of the universe. The radius of our solar system is about 9.4607 trillion kilometers, while the radius of Stephenson 218 is only 1.5 billion kilometers. Humanity has never stopped exploring the universe, and we know how small we are and how vast the universe is. Even a giant celestial body like Stephenson 218 is just a speck of dust in front of the vast universe. Therefore, the vast universe may not care about our actions on Earth. Sometimes, it is better to put aside worldly worries and pursue the life we truly desire. Why can black holes tear apart celestial bodies? Where does the matter sucked into a black hole eventually go? Does it lead to another parallel universe? Or will it disappear from this universe completely? As we know, black holes are mysterious celestial bodies, invisible to the naked eye. So how do we discover them? Pay attention to this bright halo. This is an accretion disk formed when a black hole absorbs celestial bodies. Before countless fragments of celestial bodies fall to the surface of the black hole and are completely swallowed, they orbit it at extremely high speeds, creating a strong and brilliant light through mutual friction. This is one way we can observe black holes. In April 2019, the first image of a black hole was released to the public. This is a black hole located at the center of the galaxy M87. Although we can only see the halo around it, we can be sure that the black hole is hiding here. If a star enters the gravitational field of a black hole, it will be directly attracted by its extremely strong gravitational field. According to Newton's law of universal gravitation, the larger the mass of a black hole, the stronger its gravitational field. However, the strength of gravity depends not only on the mass of the object but also on the distance between them. If a planet enters the gravitational field of a black hole, the side of the planet facing the black hole will experience a stronger gravitational pull than the other side. This difference in gravitational force will cause the celestial body to slowly stretch into a noodle shape. This is called the noodle effect. So, Does everything that is sucked into a black hole really mean total annihilation? In fact, Einstein's general theory of relativity states that gravity is a phenomenon of spacetime curvature caused by mass. Since the spacetime region of a black hole is almost infinite, all the matter sucked in will eventually be crushed into powder and fall into the center of the black hole. However, we cannot currently observe or know where this matter will go after flowing into the center of the black hole. After all, the escape velocity inside the boundary of the black hole exceeds the speed of light, and all information, including photons, is locked inside, never to escape. Therefore, the scientific community has not yet come to a firm conclusion about the ultimate mystery of the inside of a black hole. However, one thing is certain. As a black hole swallows each celestial body, its mass will increase, becoming larger with each swallow, like an insatiable abyssal monster. Renowned physicist Stephen Hawking has proposed that black holes do not exist forever. They gradually evaporate through radiation, albeit at an incredibly slow rate, even beyond the age of the universe. Calculations suggest that a black hole the size of the Sun would take 67 to the 67th power of years to completely evaporate. Although this evaporation process is incredibly slow, it reminds us that nothing in the universe is eternal. Even black holes, let alone humans, will eventually meet their end. This is an astronomical figure that is hard to imagine. The Earth is a mere grain of sand compared to it. However, people do not consider Stephenson 218 to be the largest star in the universe because the universe is simply too vast. The Milky Way alone contains hundreds of billions of stars. If we could look into the universe larger than the Milky Way, we would find galaxies everywhere, each containing an incredible number of stars, but those stars are too far away for us to observe. Among these galaxies, we have always believed that there are stars larger and brighter than Stephenson 218. In other words, although Stephenson 218 is currently the largest known star, it is insignificant in the vastness of the universe. The radius of our solar system is about 9.4607 trillion kilometers, while the radius of Stephenson 218 is only 1.5 billion kilometers. Humanity has never stopped exploring the universe, and we know how small we are and how vast the universe is. Even a giant celestial body like Stephenson 218 is just a speck of dust in front of the vast universe. Therefore, the vast universe may not care about our actions on Earth. Sometimes, it is better to put aside worldly worries and pursue the life we truly desire. Why can black holes tear apart celestial bodies? Where does the matter sucked into black holes eventually go? Will it lead to another parallel universe, or will it disappear from this universe completely? As we know, black holes are mysterious celestial bodies, invisible to the naked eye. So how do we detect them? Pay attention to this bright halo. This is the accretion disk formed when a black hole absorbs celestial bodies. Before countless fragments of celestial bodies fall to the surface of the black hole and are completely swallowed, they orbit it at extremely high speeds, creating strong and brilliant light through mutual friction. This is one way we can observe black holes. In April 2019, the first image of a black hole was released to the public. This is a black hole located at the center of the galaxy M87. Although we can only see the halo around it, we can be sure that the black hole is hiding here. If a star enters a black hole's gravitational field, it will be directly attracted by its extremely strong gravitational field. According to Newton's law of universal gravitation, the larger the mass of a black hole, the stronger its gravitational field. However, the strength of gravity depends not only on the mass of the object but also on the distance between them. If a planet enters a black hole's gravitational field, the side of the planet facing the black hole will experience a stronger gravitational force than the other side. This difference in gravitational force will cause the celestial body to slowly stretch into a noodle shape. This is called the noodle effect. So, does everything being sucked into a black hole really mean total annihilation? In fact, Einstein's theory of general relativity states that gravity is a phenomenon of spacetime curvature caused by mass. Since the spacetime region of a black hole is almost infinite, all matter sucked in will eventually be crushed into powder and fall into the center of the black hole. However, we cannot currently observe or know where this matter goes after flowing into the center of the black hole. After all, the escape velocity within the boundaries of a black hole exceeds the speed of light, and all information, including photons, is locked inside, never to escape. Therefore, the scientific community has not yet come to a firm conclusion about the ultimate mystery of the inside of a black hole. However, one thing is certain. As a black hole swallows each celestial body, its mass increases, becoming larger with each swallow, like an insatiable abyssal monster. Renowned physicist Stephen Hawking has proposed that black holes do not exist forever. They gradually evaporate through radiation, albeit at an extremely slow rate, even exceeding the age of the universe. Calculations show that a black hole the size of the Sun would take 67 to the 67th power of years to completely evaporate. Although this evaporation process is extremely slow, it reminds us that nothing in the universe is eternal. Even black holes, let alone humans, will eventually come to an end.